This video is on Learning Target 17, solving rational equations. So the first example here is we have a fraction equal to like the whole part of an expression, or having a denominator of 1 on the right side. So if this is what kind of rational equations you do have, like fraction is equal to a whole number, in order to solve this, what you could just do is clear out the fraction by multiplying both sides. So multiply both sides by the denominator, which is in this case x plus 1. So that is the first step. And again, you can only do that step if you have fraction equal to like a whole number part of the expressions, clearing up using this denominator. So doing so, on the left side, I'll still have this x squared minus 4 over x plus 1 and multiply this by x plus 1. And what will happen here is your x plus 1 on the denominator and this x plus 1 gonna get cancelled, giving you only your numerator x squared minus 4 that is on the left side. But remember, you also have to do that on the right side. So this is also to be multiplied by, let me redo that. You also have to multiply the right side, x plus 5, by the same denominator, x plus 5, or x plus 1 I should say, because we're trying to clear off this denominator. So on the right side, I will get this r to be multiplied using what you know, FOIL method or distribution. So you're dividing both sides or both term x plus 5 by x plus 1. So the product will be x squared plus, we'll have x plus 5x and then plus 5. Then I will combine these middle terms, so this would actually be just equal to x squared plus 6x plus 5, and that's what I'm gonna be using for my x squared minus 4 equal to that expression. So I'll get x squared plus 6x plus 5. And then as you were able to clear out the denominator or the fractions, the next thing you have to work on is how would you get the value of x doing or applying what you have learned in solving equations. So here we'll get this, subtract x squared from both sides, getting this 0, 0. Then the next thing that I will do, since on this side I only have the 6x, so I'll just bring it down, plus 5, getting to the next line of my equation, equals to negative 4. Then I will focus on getting this isolated or getting this by themselves on this side. So I'll do minus 5 here, minus 5. Then we'll get on the right side or left side is negative 9 equals to 6x. And then finally, as we have divided both sides by 6, so over 6 over 6, so x is equal to, we gotta simplify it, negative 3 over 2. Or in decimal, it is negative 1.5. But remember, this is rational equation. You have to consider the restriction here, what value will make the function undefined or the equation undefined. If it so happen that this value is something that's gonna make this denominator 0, you will say that you have no solution. But here, the value that will make x plus 1 0 is negative 1, and that is not the solution we got. So therefore, this is our solution for this example. X equals to negative 3/2, or we could also say negative 1.5. Okay, let's. So second example, we now have 1 over x minus 2x over x plus 2 equals to x minus 6 over x squared plus 2x. So this is not as simple as the first example because you now have three sets of fractions. So when the equation is like this is when you need to use the least common denominator. And finding the least common denominator has something to do with finding what are the factors of a certain part, like this case, x squared plus 2x, that can be factored as x and x plus 2. And then we're gonna get the union of both factors. You already have an x here, so for sure you will have x in your LCD, but you don't have an x plus 2, so you're gonna be including x plus 2 for this denominator. On the second part, you only have x plus 2, so that's what they have in common, but you don't have an x. So for this section or part of our equation, you have to include x. And on the last part, you have both. That's already the factored form, so that for the LCD that we're going to use for this example, x and x plus 2, or x times x plus 2. Then what will happen here is each part you have to multiply it by your common denominator. So your 1 over x, you're going to multiply that by x plus 2 over x by x plus 2. Then our second part, the same thing. We got 2x over x plus 2 that we have to multiply by that LCD x plus 2, and then x times x plus 2, and then equals to, let me just rewrite this again. So for this part, since this part of the equation has exactly the same LCD, so I would just keep this as is without multiplying this by anything, because I don't need to do or do have to change this to this denominator. Okay, so I'll just keep this right side as is. So now I have an x already at the denominator here, and I have this x, so I'll get this cross out. So that means 1 has to be multiplied by this. And then on the second part, I already have x plus 2, so I'm going to cross out x plus 2, leaving me only x to be multiplied with this. Okay, so what I'm trying to do here is all the denominators is just x and x plus 2. So my first part of the equation, I'll get that x plus 2, and this gives me x plus 2 as I had already canceled this, multiplied by 1, so I have x plus 2, then minus 2x multiplied by x, and then, so let me include here that I have multiplied this by 1, and then this is 2x multiplied by x, and I have a common denominator of x times x plus 2, and my right side will just be x minus 6 over x plus 2. Now I will just simplify this part. I'll get x plus 2 minus 2x squared, and then equals to x minus 6. Here I'm starting to ignore the denominator since all of them have fractions or denominator of x times x plus 2, so I can just focus on their numerator. Then here, rewriting this into standard form, I get negative 2x squared plus x plus 2, and then equals to x minus 6. And this is where I'm going to start having to move or add or subtract terms from one side to the other, so I only have all the terms on one side. So I'm going to work on subtracting this x, and that will give me negative 2x squared plus 2 equals to negative 6. Then after that, I will add 6 here plus 6 here. Then I'll get negative 2x squared is equal to, or I should say plus 8 is equal to 0, then I do have something in common here, which is negative 2, and then I'll get x squared minus 4 equals to 0. Divide both sides by negative 2, divided by negative 2. And why am I doing this? Because I'm trying to solve value of a quadratic equation. So now x squared minus 4 equals to 0. And at this point, I could just do the factoring. My factors are x plus 2, x minus 2 equals to 0. And again, what I have done here is by factoring. So as I have factored the x squared minus 4, next thing that I will do here is using the zero product property, then I will get an x value of equal to negative 2 on the first part and an x of equal to 2 on the second part. And this is where I'm going to go back to my original question. So here, what value will make, like particularly this part, what value will make this not defined? That will be negative 2. And also on this one, if I have to use negative 2, that will be undefined. So one of the values is negative 2. So with that being said, you only have this as the actual solution, and then this is an extraneous solution, because that is a value that will make the function undefined. So this is not an actual solution, this is just an extraneous solution, and the only real solutions we have is x is equal to 2.